All right, so we have reached the end of our lecture. And I'm going to say a few words about what we have learned in this lecture and what the takeaways are. So the main takeaways are that we looked at a linear model for regression, and we saw how it is trained by minimizing the mean squared error, as a function of parameters of the model. So we have also looked at logistic regression, and logistic regression is actually a model for classification rather than for regression. So the basic idea is the same. So it is trained by minimizing a certain loss function. So only the loss function is different. So for regression, for linear regression, it is mean squared error, and for logistic regression, it is the cross entropy, right? So and the reason for that is that the cross entropy comes from maximizing the likelihood of observing the training data. So in both cases, what we do is we find the derivatives of the loss function with respect to model parameters and equate them to zero. And this is basically how deep learning works too. So huge artificial neural networks are trained in exactly the same way. But for linear regression, it is possible to solve these equations explicitly, and analytically. For logistic regression, we can't solve them analytically. So we do gradient descent instead. And for just for your information, for huge deep learning models, it's the same thing. So they do gradient descent. So, and here is a small checklist of concepts that you're supposed to learn from this lecture. So that's all for today. Thank you.